What if we really don't know much about the reality we live in? Today, I want to talk about one of the most mind-bending ideas in all of physics: quantum entanglement. Imagine this. What if the most basic assumptions we have about reality, that objects are truly separate, that distance actually matters, and that nothing can influence something else faster than light, are completely wrong? For centuries, classical physics painted a picture of a predictable, mechanical universe. Everything had a definite position and speed, and influences traveled through space in orderly ways. Then quantum mechanics showed up and shattered that view. And at the heart of it is quantum entanglement, the phenomenon that even terrified Albert Einstein. The basics, superposition and entanglement, it starts with something already weird: superposition. At the quantum level, particles like electrons or photons don't have fixed properties until we measure them. Before that, they exist in a range of possibilities all at once, like a coin that's both heads and tails until you look. When two of these particles interact or are created together, they can become entangled. They stop being independent things and merge into a single shared quantum system, described by one joint wave function. They're no longer separate, they're different expressions of the same underlying reality. The glove analogy, and why it falls short. A common way to picture this is with a pair of gloves. Send one across the world, open your box, and you instantly know what's in the other. But that's classical. Everything was decided from the start. In quantum entanglement, it's different. Neither particle has a predetermined state while they're apart. They're both in superposition, yet the instant you measure one, say its spin is up, the other instantly becomes down, or whatever the correlated state is, no matter how far away it is. There's no signal traveling between them. No time passes. It just happens. This seems to break local realism, the idea that objects have definite properties on their own and that influences must travel through space over time. Entanglement says particles don't have definite properties until measured, and their states are linked across any distance without any transmission. Einstein called it spooky action at a distance, because it felt like the theory must be missing something. Why it doesn't break causality or allow FTL communication. Importantly, you can't use this to send information faster than light. When you measure, the outcome is random. You can't force a particle to be up or down to encode a message. The perfect correlation is there, but it's useless for communication. The universe gives us instant connections without letting us exploit them to break causality. The deeper implications, reality as relationships. Entanglement suggests that at the deepest level, reality isn't made of independent objects interacting across empty space. It's made of interconnected systems. What we see as separate things in everyday life is an emergent, simplified picture, an illusion of independence that hides a more relational, holistic underlying structure. Space itself starts to feel less fundamental as a separator. The universe might be one big, interconnected web, and our classical view is just a useful approximation at larger scales. This idea is terrifying and liberating at the same time. It challenges how we see ourselves and the world, as isolated individuals in a vast, empty space. Instead, everything might be more deeply linked than we ever imagined. Quantum entanglement isn't just a quirky lab phenomenon, it's rewriting our understanding of what reality even is. Experiments keep confirming it, and it's powering new tech like quantum computing and secure communication. What do you think? Does this make the universe feel more connected or more unsettling? Let me know in the comments. I'd love to hear your take. Thanks for watching. And make sure you're following our YouTube community for more secrets.